Bismillahirrahmanirrahim. With the name of Allah, who is very kind and merciful. Welcome to the My Topper Student channel. Today we shall discuss question number 3 of paper 4 mechanics, MayJune 2022. In order to search this channel on the YouTube, please use word My Topper Student. You will find the channel My Topper Student. So in this case, in paper 4 mechanics, MayJune 2022, the question number 3 is two particles A and B of mass 2.4 kg and 1.2 kg respectively are connected by a light and extensible string which passes over a fixed smooth pulley. A is held at distance of 2.1 meter above the horizontal plane and B is 1.5 meter above the plane. The particles hang vertically and are released from the rest. In the subsequent motion, A reaches the plane and does not rebound, and B does not reach the pulley. Part A show that the tension in the string before A reaches the plane is 16 Newton and find the magnitude of the acceleration of the particle before A reaches the plane. Part B, find the greatest height of B above the plane. In the solution section, first of all, according to the given statement, we shall draw the sketch diagram. Initial state of the system is the particle A is of mass 2.4 kg and its distance from the ground is 2.1 meter. Similarly, for the particle B, the mass is 1.2 kg and its distance from the ground is 1.5 meter. As the mass of the particle A is greater, so its tension will be in the downward direction. Now, using the second law of motion for the particle A. For the particle A, as the particle A is heavy than the particle B, so it will move downward and particle B will move upward. Using the second law of motion for particle A, as particle A is as heavy than the particle B, so moving downward. So in this case, as in this scenario, the tension for the particle will be in the upward direction and its weight is in the downward direction. So we shall apply the second law of motion, mg minus t, because the weight is greater than the tension. Weight is moving downward for particle A, so we shall write mg minus t. Because from the second law of motion, F equal to ma. Force is equal to mg minus t. By putting the value of m and g, after simplification, we get 2.4 g minus t equal to 2.4 a. For the particle B, in case of particle B, as the weight is moving upward, so it means that tension is greater than the weight. So we shall subtract T minus W. Like in this case, for the particle B, T minus mg, because tension is greater as the particle B is moving upward. So T minus mg equal to ma. By putting the value of m and g, and after simplification, we get, solving equation number 1 and 2, we get A equal to 10 by 3 meter per second, the acceleration in this case. Put A equal to 10 by 3 in equation 2. After simplification, we get T equal to 16 Newton. So the acceleration is 10 by 3 meter per second square and the tension is 16 Newton. We shall use this value in the next B part. In the part B, find the greatest height of B. So first of all, I shall explain we shall find the greatest height of B. It means that when particle A becomes at this position at the plane, so it means that the particle B will move 2.1, because particle A will move 2.1 meter up to the ground and the B particle will move upward same distance, 2.1 meter. So in part B. In phase 1 for particle B, as in the start the particle B is at rest, so U is equal to 0 at rest, S is equal to 2.1, because the distance of the particle B is, for the particle B is 2.1. V is equal to, need to find out the final velocity, as A is equal to 10 by 3 meter per second from the part A. By using the equation of motion, V square minus U square equal to 2AS. By putting the value of V, we get V equal to 3.741 in the phase 1. In the phase 1 we have calculated value of the velocity. Now in the phase 2, when our particle A moves to the upward direction, when the string becomes slack, that is the phase 2. So in this case, in the phase 2, the final velocity of the phase 1 become the initial velocity for the phase 2. So in phase 2, initial velocity will become 3.71, this one 3.71, and as in the slack position, when our particle move upward at this point, its final velocity will become 0 due to stall. So V is equal to 0. Final velocity of the phase 1 will become the initial velocity of the phase 2. Therefore, U equal to 3.74, V equal to 0 because at rest top is slack position. G equal to minus 10 because the particle is moving upward and the acceleration is equal to minus 10. Using the equation of motion, V square minus U square equal to 2AS. After by putting the value of V and U, the distance is S equal to 0.7. So the slack distance is 0.7. The total distance is 1.5 plus 2.1 plus 0.7 equal to 0. 1.5 initial distance from the plane for particle B, 1.5, and 2.1 distance cover in phase 1. When the particle A become to the ground, the distance is 2.1, and the last distance in the slack position is 0.7. So total distance 4.3 meter. Thank you very much for watching the solution prepared by senior A-level teacher.